Hello and welcome to another Solana tutorial. Today we're gonna talk about the kit again because I found functionality that I didn't know that the kit has and now I really want to play with it. Today I want to look at instruction plans. Yeah, because that sounds promising. Basically, it's an easier way if you need to invoke several programs because you've got a bunch of stuff that you want to do on chain. So it's not just one instruction. And maybe those instructions depend on each other and maybe they don't. And then you want to find the most efficient way to pack that in transactions and send them to Solana. You can use instruction plans to do that. But I've never tried that. But it does sound interesting and promising. So I do want to try that to let you know that that exists and also understand it myself such that I can use it. So here we go. Look at this. Previous video we looked at the documentation of the kit and I was familiar with pretty much all of those things, and then I saw instruction plans and I'm like, okay, haven't seen that, should try this. So here we are trying this. Instruction plans compose instructions into multi-step operations. Okay, instruction plans describe operations that go beyond a single instruction and may even span multiple transactions. Because the trivial case is, we just have a few instructions, we can pack it all in one transaction, it's fine. But if you want to do more complex things, then you either need to build your own custom logic to build a transaction, send it, wait for it to be confirmed, then do the next thing. And some things might run in parallel, so you can send them in parallel and confirm them, but then await them. So it's like all that logic you need to implement yourself. But those instruction plans, as far as I understand, give you that interface to do that, and then the kit takes care of all of that. So that sounds pretty cool. So instruction plans define a set of instructions that must be executed following a specific order. For instance, here we have an example. Alice and Bob need to deposit their assets. Can happen in any order, and then only then, if both of that happened, the vault can be activated, and afterwards they can both withdraw each other's assets. So in this simple example for an instruction plan, we have a sequential instruction plan. So all of those things must happen in order, this, then this, then this. But in here, inside this sequential plan, we have parallel plans where those can happen in parallel. It doesn't matter which of those two instructions happens first. So that's a nice abstract way of describing what should happen, and then given such instruction plan, we can hopefully get that to be turned into transactions and sent or something like that. Let's see. So a few notes. Here in the instruction plan, we don't worry much about, compute budget, usage and those things. We will worry about that when we actually create the transactions. We also don't worry about building transactions yet, and sending and signing, that comes later. With the instruction plans, we solely focus on describing operations and then delegate all the other things to transaction planners and then transaction plan executors. So those are the steps. First, we have an instruction plan. Then we use a transaction planner, and then we use a transaction plan executor. So yeah, there we go. That's an example. So from our instruction plan, we create a transaction plan, and from that transaction plan, we use a transaction plan executor that then executes the transactions, and then we get a result. Okay, on a high level, seems easy, but what's behind all of that? Let's have a look. This separation of concerns not only improves the developer experience, but also allows program maintainers to offer helper functions that go beyond a single instructions while leaving their consumers to decide how they want these operations to materialize. So basically, you're telling me those are nice interfaces that you can implement yourself or use the default implementations that will handle the stuff if you want to handle it in a certain way. Okay, let's just get started and use this at Solana instruction plans, which, let me guess, is also in the kit. But if we just want to use instruction plans, we can just import that. You know what? It's time for coding. Alright, PMI Solana instruction plans. And then we create a new file, planning. And let's see what we can import from here. Parallel instruction plan, sequential transaction plan. Yeah, there you go. Now I have the interfaces for that. So an instruction plan has a get message packer, can be parallel or sequential, and has the instructions. or can be a single instruction. Okay, I don't think we need to look at the interface yet. So let's get started with creating instruction plans. This package offers several helpers to help you compose your own instruction plans. Let's have a look. Single instructions. That is the trivial case. A single instruction plan, which is just one instruction. A plan where we do one thing. It's a simple plan. I just need to do one thing. And sometimes I even fail to do those things. Sometimes my plans look like this. I just have one thing to do and I still don't manage to do it. But this is my personal to-do lists. Those instruction plans will be different, I hope. So let's create a simple instruction plan like that from a single instruction plan that we can import from here. And this thing takes an instruction which lives in Solana instructions. So guess what? We gotta get instructions. That's not what it is. Instructions. Solana instructions. Here we shall have an instruction. Now while we're here, let's do Solana program system and get some proper instructions, like get transfer sol instruction like this suggests. So my transfer sol, I'm gonna call it transfer sol instruction, is a get transfer sol instruction from, for this to actually work, I need to work. Fine, let's get a key. Why not get myself another key with my name? And if can I get an airdrop? No. Shit. I found the right package that's in signers. Wonderful. Oh, and then also get this, and there you go. Now I have a signer. Now I can finally move on. So source from my signer. Oh wait, not just the address, it needs the signer. There we go. Destination unknown. I just get a new signer. Or should I just, no, I'll just hardcode an address. Oh, that's in Solana address then. No, where would address live? Addresses. Okay, so Solana addresses should have address. Sure. And my destination from me to you. There you go. Not gonna actually use that key pair, but just the address. To send you, oops, the amount of 0.001 sol. There, have it. And that instruction I'm gonna put into my single instruction plan. Coming back to the instruction plan. So far so simple. What can we do with this instruction plan now? There is the instruction and there is the what kind of instruction it is. In this case, a single instruction. Oh well, nice. I think even before we look at, sequential plans and everything, let's go through the entire procedure of coming from the instruction plan to the transaction and sending it. Because there we then use the transaction planners. Transaction planners are defined as simple abortable functions that transform a given instruction plan into a set of built transaction messages called a transaction plan. So, transaction planner. Creating a transaction planner. You must use the create transaction planner helper. This helper requires a create transaction message function. Therefore, each transaction message should be created before being packed with instructions. Okay, here we then add all the transaction specific stuff like, do we want to send version transactions? Who's going to be the fee payer? And so on. Additionally, on transaction message updated function may be provided to update transaction messages during planning process. Okay, well, let's create ourselves a transaction planner then. So, transaction planner is create transaction planner, which takes a config, which is create transaction message, and optionally the on transaction message updated. So basically, this is what we will need to implement, because this I think is a function. No, this is a create transaction message. Yeah, but it's supposed to be a function. Okay, so we just create this neat little arrow function here and say, oh, it must return. Here it already complains that void, I cannot return nothing, void, because what we need to return is this instructions, the transaction plan. What am I actually gonna return here? Just gonna borrow this code here. And I guess I don't know where all of those things live. I'm just gonna get the kit now. It just makes development easier. And then from the kit, I can get pipe and all the things that I need and create transaction message and do this. So here I'm gonna use my signer that I defined up here as the fee payer. That is transaction level. So it's not for the instructions that I give this fee payer, it's for the transaction that I give this fee payer. Okay, that's the pipe. And then what I get back here is the message. And then I guess I gotta return the message. I could just return the pipe for this to be happy. How do they do that? Oh, they don't have a Ah, I see. So that's the long way of writing. If I remove that and just say it's this, that's the shorter way of writing this. There you go. So yeah. But actually, I don't like how that looks. I'm gonna do this, then it's clear. Then I'm not so confused myself with the indentation. Then it's clear. In here, we actually create this message, and this message is what we return here. So that function returns the message, just a v1. I could also do a legacy one, and I set a fee pair. I don't set any priority fees or anything here. Also that I would probably do in here if I wanted to add priority fees. Or a block hash. Where would I set the block hash? Wouldn't I set the block hash in here? We'll get there. Maybe not yet. We'll see. For now, it's just we set the fee pair and the version, and then we can use this transaction planner to get a transaction plan from the planner by providing the instruction plan and an optional abort signal, which I don't care about now. So just, I don't need to abort this. I don't want to even attempt to abort this. So just going to do this, and then, I'll await this, and then I'll have the transaction plan. So that's how this looks like now. We create an instruction that we put into a single instruction plan, which we then put in our transaction planner to get the transaction plan. So far, so good. What do we do with that transaction plan? Let's get to executing transactions with transaction plan executors. So we need a transaction plan executor that will let us execute the transaction plan again. Same thing as before, it takes a abort signal, and for that we need to have a transaction plan executor. So we need to create a transaction plan executor, which again we do with this nice little create transaction plan executor. So there are functions for everything. But what is the transaction plan executor actually doing? Tells us how each transaction message should be executed when encountered during execution process. This function accepts the transaction message, so not the instructions anymore, but already the packed message, and returns an object containing the successfully executed transaction. So this is already then executing the transaction. Yeah, makes sense. And here we will add the latest block hash or other lifetime, and we will sign it and send it to the network. So we will use the send and confirm transaction. Okay, let's start here. When we create the transaction plan executor, what we need to implement is the execute transaction message, which takes the message and returns the transaction that was executed. Yeah, because here we will add a recent block hash, then we will sign the transaction, then we make sure that it's sendable, and then actually send it and confirm it. So the transaction plan executor defines how the transactions are actually sent, which RPC to use, and so on. So yeah, let's implement the transaction plan executor. So transaction plan executor with create transaction plan executor, which takes the config, which needs, why is that twice in here? We'll see. So this thing takes the message, and what we do with it is we gotta build an actual transaction, add block hash, sign, send, confirm, return the transaction. And because I'm lazy, I'm gonna copy that. And then I will also need this. And for this, I need the RPC and the RPC subscriptions. Create Solana RPC from this, and RPC subscriptions. Create Solana RPC subscriptions from this. There you go. Okay. Then we have an await in here where we are not async. Can I make this async? Yes, I can. Wonderful. So basically, this is nothing new. We created the RPC connections, create a send and confirm with this factory that we then use down here to actually send the transaction, where we first added the block hash to the message, signed that message to make it an actual transaction. Because, you know, the message part of the transaction is just all that information, that what's the fee pair, what's the block hash, what's the instructions, what's the lookup tables, and so on. And then if we sign the message, we add the signatures, and the signatures plus the message make up that transaction. That's why here we call this transaction. Then we check if it's a sendable transaction. What does that actually do? Nobody knows. But that ensures that it has the right type down here, because otherwise last valid block height is not declared, or that's why we check that it has a block hash lifetime, just that to ensure that it has the right types here. And why do we ensure that it's a sendable transaction? No idea. Probably that it has the right size and whatever. Otherwise this will fail and then we don't even attempt to send it. Fair enough. It's in the example code. I'm just gonna do that as well. And then we return this transaction. That makes sense. Yeah, okay. We send and confirm, and then from this we can then get the signature and whatever. But also we know what exactly we sent, just in case we want to check what the transaction plan executor changed. Anyway, now that we have this transaction plan executor, we can execute our transaction plan. So our transaction plan execution result, great name, not too long at all, is if we await the transaction plan executor and give it the transaction plan. Simple as that, right? And that has a kind, that's all. Now what do I do with this result? The results. When you execute a transaction plan, you get back a result that tells you what happened during the execution. Can be successful, failed, or cancelled. The transaction was sent and confirmed. In that case, you get the original message and the executed transaction object. Failed, the transaction incurred an error. You get the transaction message and the error that caused the failure. Or cancelled, the transaction was skipped because an earlier transaction failed or operation was aborted. You only get the original message. Okay, if your transaction plan looks like this, your result may look like this. Successful single transaction plan. Right, so for every part of the plan, we get a result with success, failed, or cancelled. For now, we just have a single instruction. So we will get a single result, a successful single transaction plan result maybe, or unsuccessful, who knows. And if it fails, when we use this create transaction plan executor and the transaction fails, then we will get this error, which contains a transaction plan result property. Okay, I'm just gonna borrow this and paste it here. So this is what we're doing. And if we get this specific error, then we can, from the error context transaction plan result, get this type. And this result, let's just log execution failed and then look at the result. And if we don't get that error, we say execution succeeded. And I'm just gonna print the entire result here, just to look at what that looks like. So that's the entire thing. I mean, it is, admittedly, if we zoom out, still a bunch of code that I wrote here to get this done, but mainly because the builders take up so much space. Like I need to define my transaction planner, my executor. But once I have that, it's pretty simple. If I would define all of that up front, let's say all of my definitions like this stuff I did up here, like this, that's just setup, which is nothing special. Then suddenly it does look not so complicated at all. Because really it's just those few lines of code here. You create the instructions, put them in an instruction plan, put the instruction plan into a transaction plan, and put the transaction plan into a transaction plan executor, and you'll have a result. That's it. And admittedly, for a single instruction like we have here, you don't really need the planner. You could have just put that into the transaction directly, like here. But when it gets more complex, then it could be helpful. But before we look at more complex examples, let's see if that actually works. So far we haven't executed anything. Do you think it's gonna work first time if I call my planning script? Nope, it does not. What am I trying to import? Wait, what? Cannot find module. What is that, WebSocket? This requires WebSocket. I see. Can I add that and then try again? Yeah. Ha! Look at this. It's successful. Execution successful, and that's the transaction plan executor result, which gives me the kind. It's just a single instruction where we get the entire message. That's the transaction. That's the transaction it built. In this version, that's the instructions. It has it in here, just printed as an object, but all the infos are in here as well. That's the fee payer, and the status is kind successful. It gives me the entire transaction and even the signature. Okay, so can I here say result? Why? Here I don't have the types, I just have the kind that it knows that it has. So how would I correctly type check if that was successful now? I mean, I can assume that it's successful if I don't get an error, but I also, just for understanding, the message is what came into the executor, and then the transaction is what the executor made of the message, and then and whether or not it's successful is in the kind, and the signature is also here. But I still don't quite understand how I can now, from such a result, see if it was successful. Do I have something in the instruction plans for that? No, I can't just create it. Successful single transaction plan result. But that will create me a result. So basically what I want is, I want this as a single instruction plan result, which I think it is already. No, it is not. Because then I could access those values and say status kind is successful. Wow, it even suggests that. Or the other way around, if it's not successful, something went wrong. And then, I don't know. But I'm not entirely sure if here I only get with success anyway. Because with error, we should get here. If transaction execution is an error, we should already here throw it, and then, or here the executor should already throw it, and then we catch it here. But what if it gets cancelled? Does it also throw that? Let's first just check what would happen if, say, that transaction would fail for whatever reason. For instance, if I were to send 100 sol, that money I don't have, so this transaction should now fail. Failed, there you go. And we get to the execution failed. It again prints me the message from what goes into the executor, and the status just has the error and the kind failed. Transaction simulation failed. There you go. And then in here I have the details why the transaction simulation failed in the context. But also here I can't access the status because here's just a transaction plan result. Oh, because it doesn't know. I see. Because it has the status for every transaction, and there could be more transactions. Obviously, there's not just one status. There's just one status if it's a single transaction. That makes sense. Okay, I'm just gonna say that you have the status because I know, hold on. Because I know, like here, this is a single one. I can also say here, the result, I know it is a single transaction plan result. And then I can access from this single the status, which has the error, which has the context. And would I here, I mean, I can just check if, you know what, let's do it better. Let's do it properly. If the result has a status, no, kind is single, then in here it should already understand from this result that it's a single and give me the status. Yes, perfect. And then I can play this further. If result kind, no, not kind, status kind is failed, then it should understand that the result should have an error. There we go. The result status now has an error. That's the proper way to do this, I think. We don't have an underline kind, so I'm expecting the kit wants me to use this. So yeah, if we have a single transaction result that failed, then we have that error, and that error might have a cause, and so on. So I'm just gonna print that error cause, because that's where the real message is hiding. There you go. Solana error, custom program error 1, context code for transaction index 0. I still don't get the logs. Is that in the context? Maybe that's in the context. Because the message it did print, right? Yeah, the message is just transaction simulation failed. I don't see how I can get to the logs of the transaction simulation. Can I JSON print this? Can you print this in that format? Let's look at that entire error. Nope, again, begin can't. Damn it, it's annoying that begin doesn't serialize. Okay, so I don't see the logs of that simulation, which is a bit annoying, but okay. We still get enough information that I understand what the issue is. And probably it's somewhere in there, isn't it? Maybe we don't get that out, but that's fine. So we know we get here if that's unsuccessful. Let's also properly do that up here. Only if the result kind is single, we do that. And when it gets cancelled, I don't know what happens. We will see. Okay, but that was now just for a single instruction plan. And that's not really super helpful. If you have a single instruction, you might as well build the transaction yourself and then send it the normal way. Why go through the effort of creating a transaction plan executor and the transaction planner? It's all a bit unnecessary for just one transaction. This stuff really just gets helpful if we have several instructions. So let's do that same thing with several instructions. And because I'm lazy, I'm gonna do 3 times the same thing. Let's call it 1, 2, 3. And we transfer more and more 0.001, 0.002, and then way too many. In sequence, I want it to first do this, then do this, then do this. So instead of this single instruction plan, let's do a sequential instruction plan. And that sequential instruction plan takes an array. So here we say, do the transfer sol instruction 1, then 2, and then 3. In that order. And the rest of the code can stay the same because I just changed my transaction plan. The transaction planner is still the same. It's still this. When we create a new message, you would do this. And I think the transaction planner has the logic for if there's enough space in that transaction, I'll pack more and more into this message. So what I would expect if I have 3 instructions, that I still just get 1 transaction back. So this transaction plan will now also correspond, and we saw that in the docs, I just didn't go over it. So the transaction planners, the transaction plans, they will correspond to what we put in, right? A single transaction plan wraps a build transaction message. Sequential transaction plan wraps other transaction plans that must be executed sequentially. Non-divisible sequential transaction plan wraps other transaction plans that must be executed sequentially and atomically. So here it suggests that it should use bundles, because otherwise it's just atomic on transaction level. If you have several transactions that you need to execute atomically, then you need to use bundles. Otherwise the plan should fail to execute. And a parallel transaction plan wraps other transaction plans that may execute in parallel. Okay, hold on though. If we just have a sequential instruction plan, we might still end up with a single transaction plan. So it says they work similarly to instruction plans, but wrap transaction messages instead of instructions. Makes sense. So let's see what type we get. In fact, I'm just going to log the entire transaction plan, but I would expect the transaction plan kind to be still a single transaction plan. However, I expect my instruction plan kind to be, oh guess what, a sequential one, because that's the only choice that there is. It must be. That's so cool. Because I said it's a sequential instruction plan, so obviously it's a sequential instruction plan. But then the transaction planner, here it doesn't know anymore if it's a single or a sequential, because it doesn't know how many instructions it is and how they can be packed. So yeah, let's check this. And the result here should still be single then though, because I'm still expecting this one to be single, so this should all still be the same. Let's just check this. Let's just run this. Okay, that's cool. There we have it. Code 1, insufficient funds. Index 2, so the third instruction failed. But let's start from the top. So it's a sequential instruction plan, as we said. It's a single transaction plan because all of those 3 instructions fit into one transaction. So we get a single transaction still. Nice. And then same as before, just that the message now has 3 instructions. But then the execution failed with the error transaction simulation failed because custom program error 1 of the system program. I wish I would get more details on this, but hey, you know what? If I want more details on this and I'm like, you can't get the result. You know what? If you're unhappy with this, just simulate it again. It's my simple solution. We failed anyway, so why not? Because we do have the transaction. It's in here, result. Not just the message, but the entire... No, we don't get the transaction. We just get the transaction if it's successful. Hold on. Here, in the transaction result in the status. Oh, we still didn't check the kind. No, we checked the kind for successful. We know it's single and successful, and we still don't get the transaction. That sucks. But we did get that transaction in here. So status. Yeah, we just get the error. Here we don't get the transaction. Wait a second. If it would be successful though, let's say I transfer 0.3, that should give me a successful transaction. There we go, and it manages to confirm that. Then we even get the entire transaction here, and that I could re-simulate. But if it fails, I don't get that. That's annoying. And I see why. Because my transaction executor, it can fail because it can't sign the transaction, or because it can't get a recent block hash and then it doesn't have the transaction yet, right? It's not just that it fails here at the send and confirm. That's why we don't get the transaction back. So let's say if we get here, if I really wanted to see the simulation, I could just add that here. Just use my RPC again to simulate a transaction. This one. Wait, why can I not simulate this one? Can I do it here? Quick fix. What do you need? And get base 64 encoded via transaction of this. I think the transaction type is something else than I expect. What's my problem here? That I can't put this transaction... No. What am I doing differently now? Don't ask me what I'm doing differently now. If I plug this in here, now it works. Oh wait, that's send transaction. Hold on. I wanted to simulate transaction. But also that works. Anyway, so I'll log the simulation result. If I want to have a simulation result because I'm interested in the exact error, I can do it in my executor. I can do whatever I want in my executor. This is the thing doing the execution. I could even here already say, hey, if simulation result value error return, or maybe I can throw this. Already failing in simulation, whatever. That way I should get the same result. So this way I should be able to now get the simulation. Here, look, in this case it's all successful, and then the execution is also successful, and I even get the transaction here. But for the failing case, if I send too much sol that I don't have, then I already fail in simulation, and I see my logs here, 0x1, insufficient Lamperts. We don't have that many. But then I still get execution failed, and I still get here, I just get status failed because I'm not providing more information. And the thing I'm doing down here with getting the error context transaction plan result is undefined. So maybe I shouldn't do that without providing context. You know what, I'm just not going to do that and let it fail in here, and then it gives me the right errors anyway there. Then I get execution failed, transaction simulation failed, and then I can decode that stuff again because I have access to this transaction plan result in here again. Yeah, good. But I also see my simulation up here. So that's something. Again, if you have several transactions, then it might be difficult again to see which one was that now, but it's the one that fails. So yeah, anyway, but that's cool. Simply for the fact that I don't need to manually pack this. Because what happens, and I'm just gonna recycle the instruction number 1, put instruction number 1 in here for a few more times. Actually, no, that's not gonna help. That doesn't really make the transaction much bigger. You know what? We need to make our transaction bigger. So what if we had like a lot of instructions? Transfer to random address. Get transfer sol to random address instruction. And this thing will return maybe this thing, but to a random address. Just generate a key pair signer and get me the address. Or can I do this async? So we send to a random address is what that's doing. And then instead of doing that manually so many times, and then define my structure an array with how many are we gonna do? Let's do 10 to start with. 10 should still work in one transaction, honestly. Get transfer sol to random address. And then we put my instructions in here. Maybe I need to map this differently. Map this. How about this? How about this? There we go, that looks better. Okay, I think I managed now. So, with those instructions, if I put them into a sequential instruction plan, those are now 10. Welcome to Texas. Transfer sol instructions. could probably still fit into one transaction. Yes, look at that. We're doing transfers and it's still successful. Let's look at that signature just to see that actually, that's cool. That's new. CU profiling. All of them are 150 compute units. So yeah, that looks like one of those spam transactions that I'm doing here. Great. But yeah, it's still neatly packed. Does it show me the size of it? Doesn't show me the size of the transaction, how far we're off. Because I'm pretty sure that the transaction planner takes care of that. And that transaction planner, while we're here, the transaction planner also had this on transaction message updated. I think it adds all of the instructions here when new instructions are added. There we go. So message. It's not assignable to type on transaction message up. Void is not assignable to. What do I need to return here? The message. There we go. So here on message updated, I would do nothing, but I could do something with that message. For now, I'm just interested. Get encoded size, get transaction size. Which one of those do I want? Gets the encoded size of a given value in bytes. Gets the size of a given transaction in bytes. So that's the transaction already with signatures, and I only have the message so far with the instructions. So I can't put the message in here, can I? No. Okay, fine. Just to see. I just let it print that for fun right now. Just to see that, yes, that would be called 10 times. But I'm not doing anything with it. So I really want that. Maybe I need to do that in the execute. I'm just going to do it in the executor real quick. This transaction after I signed it, get transaction size of this transaction. Just because I'm curious how big that already is. And we are currently at 658 and max transaction size is 2000 something. So we gotta add more instructions. So let's do 20. That should still work. But we're getting bigger. We're now at 1100. Let's do 40. This should now be too big for one single transaction. And here you go. Did you see that? There was 2 transactions. Look at that. That's so convenient. Wow. And now, okay, so it's a sequential instruction plan. So far, so good. But then it's not a single transaction plan anymore. It's now a sequential transaction plan. Kind sequential. Divisible is true though. So sequential can have divisible and non-divisible. Interesting. And the plans are 2 single. So there are 2 single transactions now. There's one sequential plan that basically has 2 single transactions. That makes sense. A first transaction has this size. Second transaction has this size. So it's split it into 2 transactions. That's fun, isn't it? And I didn't have to do anything for it to do that. I just told it, hey, send all of those transactions. And it just did that. And then the execution was successful. And we have 2 single results. So one sequential. Again, it's the same format as this up here. So that's how my transaction plan looks. Then the transaction plan result will look the same way. So again, we have a sequential divisible transaction plan result for the 2 plans. This one started, I guess both of them are successful. I'm not printing the inner thingies. I should, maybe. But yeah, we're expecting that both of those are successful. Okay, what if I add another? Let's add an impossible instruction where we transfer 10 sol. Add that to my instructions here. Let's see what happens here now. Let's execute that plan. Okay, now we get execution failed. Wait, earlier we got success, right? Yeah, earlier we got success. And now we have a sequential instruction plan and a sequential transaction plan. Divisible is still true, which means the first one was probably sent, but the second one was not. Here, insufficient Lamperts and execution failed. I'm still interested in that status if this one was sent now though. So maybe we should traverse that. How can I print that better? If it's a sequential plan, then it has plans. So what I need is kind of a print plan result, which takes a execution result and basically does what we're doing down here. If it's a single result, transaction failed, then I'm gonna print the cause or the entire error, why not, or both. And for completeness, we also have canceled. So that's for the single case. I'm gonna work with intents. Level, recursion, depth, I don't know. How about this for some nice printing? This is just a helper function for me now. So that's for the single case. For the sequential case, if it's sequential, I'm just gonna print sequential plan, and that inside that I'm gonna, for each plan, recursive call the print plan result with that plan and a depth +1, and then the same also for parallel. Do we get anything else in the parallel? No, it's the same. The sequential plan can be divisible or not. We will have a look at that in a second. Let's just see if that printing would work. So that's for the error case, and I will also print it here. It's both the same thing. Up there I call it differently. Well, never mind. So let's look at that, if that looks any good. Yeah, so it does look good up until here. So that's a plan that failed because it's a sequential plan with the first transaction successful, so that's what's in here, and the second transaction failed, that's what's in here, and then I printed why it failed. So custom program error 1. Yeah. Oh, and here in the context, I do get the logs though. The context has the logs. Look, I don't even need to simulate that up front like I did here. Perfect, so I can get rid of that. Don't need to simulate that here. Look, we're still in that error. Perfect. How am I printing that differently now? I don't know. But if I print the error, the Solana error, the context, it gives me the logs actually. Nice. There we go. And then I don't even need the cause. I don't need to log the cause. That's actually here. I don't need to log the cause extra. So, but now I have an important question. Does it actually send the first transaction? Because I would think so. The transaction is successful here. Can I actually, while we're printing it, transaction successful, can I have the status signature, please? Because if it's a successful transaction, then we should get a signature for it. Yeah, look, transaction successful, that's the signature, and that's actually being sent. So we do send that all the time, those transfers. The first, I don't know how many transfers are being sent. The second batch of transfers is not being sent because there the transaction fails. Because I have one instruction in my plan that is impossible or that will fail. So yeah, this is a sequential plan. It goes one after the other, but it doesn't stop. Like it's not atomic. It expects that all of them go through. So what would change if I have that failing transaction in the beginning? Then it shouldn't send, because then the first one should already fail and the second one should get cancelled, right? Because the second one can only execute, since it's sequential, after that. So let's check that. Here, there we go. Transaction cancelled. So the first one already failed, and then I print a bunch of stuff why that failed. Look, here it's why it's failed. And then the second one got cancelled because the first one didn't go through. That's cool. But then we're also talking about this non-divisible sequential transaction plan. When would a sequential transaction plan be non-divisible? Like, what do I need to put in my instruction plan? Oh, probably a non-divisible sequential instruction plan. That would make sense. So if instead of, where do I create it? Here, a regular sequential instruction plan, which just means send them one after the other, but if you get stuck at some point, that's fine. If I want all or none, I need a non-divisible sequential instruction plan. And then I'm gonna put that at the end again. And then my instruction plan will be non-divisible. Therefore, my transaction plan will be undivisible. So let's see what happens if I do that. Oh, it's still false. It's a sequential transaction plan, but it's... Oh, no, divisible is false. Before, divisible was true. And then we get execution failed. Divisible is false, but it still executed that because my implementation is shit. Because I'm not having the right implementation. Yeah, it still did that. Because I'm not taking care in my executor. Wait, how would I take care of that? The executor will traverse the provided transaction plan sequentially or in parallel, executing each transaction message using execute transaction function. But do I have access to... Here I don't have access to whether or not... Hold on. Well, that's weird, because my non-divisible still is divisible. I mean, it still divides it. What should happen is that the executor fails and says, hey, this message is part of a non-divisible thing and I can't do non-divisible with that thing. I should use bundles somehow. And if I don't support bundles, then I should not support this message. But I can't because I don't have access to whether or not that's a non-divisible message. That sucks. And also here, when we create the message, we have no idea about it. When we update the message, we also have no idea about it. So that still sucks, honestly, from the design. Because how would I know if I'm supposed to use bundles here or not? That sucks. Okay, so basically that's just not working. I might as well use a regular sequential instruction plan that is divisible, because that will give me the same result. Now, divisible is true, execution still fails, but the first one will still be executed. So yeah, hey, people who developed the kit, what did you think about that? Like, how can I fix that? Like, how can I tell my plan executor to use a bundle in that case? That's confusing. So I'm gonna put that on my list of things I still need to figure out about this. But honestly, hopefully that's a edge use case, because really, if we're really honest, the thing that I'm doing here, sending from one account to other random accounts, really is not a sequential thing. Really, this should all go in parallel. So I should create a parallel instruction plan. And then we know it's a parallel plan, forget about that. And if it's a parallel plan, let's see what would be different. It still does 2 transactions, because it can't fit into one. But this time the type is parallel. We have a parallel plan and we're executing 2 transactions, but they are executed in parallel. Because it all went so fast, I'm going to throw that out and then I'm going to keep talking and we're going to look at that. And we see how both of them came back at the same time. So that was basically executed at the same time. Look how that was faster than when I had a sequential instruction plan here. Because if I had a sequential instruction plan here, then it first sends this one, waits for the confirmation, and then the second one. But with the parallel one, it does actually do both at the same time. Boom, faster. Yeah, those we can definitely send in parallel because they don't depend on each other. There's all just doesn't matter who I pay first. So yeah, that's actually quite fun. And then obviously you can have more complex stuff of having a bunch of parallel stuff with sequential stuff and parallel stuff and sequential stuff and single stuff. And you can build the transactions as you see fit, right? I could say, hey, I want to send 100 transfers in parallel and then afterwards sequentially. So after I send all of them in parallel, I'm gonna send my impossible transaction or whatever. This is just random. This is just an example. But yeah, first you want to pay everyone and then you want to do something else, whatever. In this case, I will have that fail. So let's see what my transaction planner makes of this. Look, it does several at once. That's cool. Look, it had 1, 2, 3, 4, 5 transactions for sending my 100 transfers and then another separate transaction once they are all done. And that's what it looked like. My sequential plan consists of a parallel plan, which were all successful, but then afterwards, this transaction failed in a single plan. And yeah, you can make that as deep as you want. A sequential plan and a parallel plan and a sequential plan and so on. But that's really cool. It's so cool that I can just say, hey, here are my 100 transactions that I need to send. Think of you write a lot of data on chain into a big buffer account. You just create all of the instructions and that way you don't need to bother about the transaction packing, like how much fits into each transaction. I read something about that. Message packer plans are a bit special. They can dynamically pack instructions into transaction messages. And then you can do such cool stuff like put in as much data as can fit the message. That's cool. And there's so much other cool stuff. The non-divisible thing, I think it makes sense if it's just a few instructions that don't span several transactions. Then that already makes sense that you use it, because then the planner will put it in the same transaction. So for instance, in our example, let's say I had another sequence of, I don't know, 3 of those that transfer a bit more. Let's say I put the amount here. Let's say this would send a little more, and those I would then put as a non-divisible sequential instruction plan into my parallel instruction plan. But here I just need to have, can I do that directly like that? Can I mix instructions with another plan? Seems like it. Let's see. And I'm gonna remove the impossible transaction again. So I'm expecting those 3 to end up in the same transaction, but it might also add some more instructions in the same one. Let's see what happens. There we go. Okay. Interesting. Look, this is so cool. This is so cool. I love this. Look, because it pretty efficiently packed that into 5 transactions. And all of them were successful. But I'm pretty sure it's still guaranteed that those instructions were non-divisible. So all of those instructions were in one of the transactions. And now I have to guess which one it was. Can be any of the 5. Because parallel. And indeed it was, no. Yes. Look at that though. It was this one. Here's one of the 3, here's one of the 3, and here's one of the 3. They were all in the same transaction, so they were sequential. They were here at the very bottom, it put those 3 into this one transaction. And if I increase the number of the 3 to, say, I don't know, 20? Let's do that. Then we get 6 transactions. And this one was a little smaller because now it couldn't put them in here anymore. And all the 20 were put in their own transaction. So they were not split. That's so cool. And you don't have to manually do anything for it to accomplish that, as long as it still fits into one single transaction. It won't work if you have, say, I don't know, 40, because then it will split them they will have to split them between 2 transactions. We get divisible false, but I don't have that implemented, that this sequential plan will then actually also be executed atomically. That's the problem. If one of them would fail, then it's not supported by my implementation. But cool. I like that. This is so nice. And there is so much more that you can do with this. Advanced transaction planners. You can write your own transaction planner if you have some specific way how you want to order things or whatever. And also advanced transaction plan executors if you want to implement custom execution strategies, such as using transaction bundles for atomic execution. There we go. So if I want to support bundles, then I need to create my own executor, because then I can work on the plan. Yeah, that makes sense. And maybe we keep that and many other things for the topic of a future video. Obviously, you can also add transaction fees. You would do that in the transaction planner when you create the message. You can estimate compute unit costs, and you can use durable nonce lifetime instead of block hash lifetime. So this stuff is versatile. I like this. And what did I get stuck on? Oh yeah, the message packer. A custom message packer, that might also be the topic for another video. I think I'm good with what we looked at today. I think we got a good idea of what those instruction planners are and how to use transaction planners and then the transaction plan executors. If you have to send a bunch of transactions, this can really be so helpful because you don't need to do all the logic yourself, how to pack them and how many transactions to create. That's actually really nice. And it's also pretty flexible. You can implement your own execution strategies and your own planners. So yeah, it's a pretty cool topic. And I didn't know, like before today, I didn't know that was a thing that the kit can do, but now we know. So that's cool. I enjoyed that. And I think I'm gonna leave you here. Let me know if you want a further deep dive into building a custom packer or a concrete example of how to write a buffer account, how you would implement that. Because it's so powerful and fun. I think I'm gonna make another video. So make sure you are subscribed and give this video a like if you enjoyed it. You can watch some other videos until then. And I will see you in the next video, talking about some nice functionality of the kit or some other Solana dev tool. Until then, enjoy. Bye bye. It's fun. I like learning stuff. And I like that they make it easy for devs. It's pretty cool. I enjoy that. I enjoy those instruction plans and transaction planners and stuff. It's a cool thing to have if you know how it works. Which we totally do now. Peace out.